Welcome to our next panel. And this will be, I promise, an interesting one for all of us. It's called Hardware versus Software, or is hardware dead? Or better, is FPGA dead? We as a system integrator, our business model is based on cascading hardware, interconnecting hardware and find the best way to interconnect the hardware. And what is hardware nowadays? It's FPGA. We have a camera, a lens, a sensor, an FPGA. Then we transport the signal, then the next FPGA. Distributing, processing, to the vision mixer, FPGA. So, and our knowledge is how to interconnect all these FPGAs. And for sure, we sell all these hardware devices, and we add some very, very small margin on it. So it's our business model. And now, guys like my friend Kuban comes and tells me that's not the way it will be in the next years. So we will have a very interesting discussion with all these guys here, and David will host this panel as before. Thank you.
Thank you. So a little earlier on we heard that from some quarters a belief that SDI must die, and now we move on to consider whether hardware is in fact already dead, if not ailing. So joining us to discuss this, we have a great panel. I'm going to ask them to introduce themselves from left to right, and just give us a little bit of background on their current role.
Pierre Mestrez from Simplylive. I've been in the live broadcasting industry since 2000, ex-EVS employee and also working on the DeltaCast. So I'm specialized in live broadcasting workflow, sports production and entertainment.
So my name is Laurent Petit. I'm head of product management for the live production part at EVS. I'm working there for close to 10 years now, working amongst others on the server side, which is a piece of hardware that you know all of. And so it would be an interesting discussion today about that.
Yeah, my name is Marcel Koutstaal, and I'm very pleased with the statement "hardware is dead." That will be challenging for us. I'm responsible for the camera business for Grass Valley. I'm vice president and general manager. I'm based in Breda, in the Netherlands, which is the heart of the center of the camera division for Grass Valley. I'm in the industry since '98. Working with the LDK23 super slow-mo camera, working with EVS machines in that time. So quite an history in the broadcast environment. Working always with cameras, and with this subject, it's for a reason.
Yeah.
Okay.
Hello, I'm Kuban. I'm from Zero Density. I'm responsible for research and development at the company. My roots are coming from the game development in the old days. Then I moved to visual effects and post-production, then moved back to broadcast. So now we are combining the game engine technologies and visual effects and post-production workflows for the broadcast industry. So we are creating real-time compositing and rendering tools which are purely designed to work on the GPU in real time, which enables real-time visual effects workflows. So implementing that kind of stuff for many years, I see many things are possible with software running off-the-shelf hardware.
So a nice, straightforward one to begin with. Who agrees with the sort of declaration of this session, and who thinks that it's that hardware's demise has been somewhat exaggerated?
I think it's a combination of both answers. Yeah. Certainly at this stage, where if you want to go to full software solutions, there are a lot of pieces that need to evolve to newer technologies. IP is definitely an enabler for more software solutions. And we at EVS strongly believe that we have to combine both elements to create the live production of today. Now, going further tomorrow, there will be more and more software, definitely running on not necessarily on dedicated hardware, but more on general purpose devices. And we are doing that already with some of the products that we have today, like our DV Vision Mixer is a good example of that, with a pure software-based vision mixing solution, but some components inside that still need to remain hardware at the SDI level, but also at the IP level in order to achieve the throughput that is involved with the high bandwidth we have to cope with in a live production environment. And I think that's today, this is the best answer that we can provide.
Yeah, and it also depends on what you define hardware.
Yeah.
Yeah, and even a computer that has to process is hardware. So the only software will run on hardware itself, so that's always required. And what I learned when we introduced software licenses on our cameras, we learned that it's difficult for the industry to understand the value of software, where the hardware is known, and that's also where Reiner is making his margins from. We have to understand the value and the investments that are being made in software, besides the investment that most of the time the industry understands that's an effort and an investment that the manufacturers are making in hardware, but that's also valid for the software developments. And that have to be recognized, otherwise it will never happen.
With nowadays components directly available off the shelf, we can create a large set of powerful device and develop the software in the way the component can be reused and offers a specific flexibility in the way the product are built. I think this flexibility linked to the software is also the flexibility that we offer to the customers who want to repurpose and reuse their equipment for multiple kind of production, multiple let's say features. And it fit also as a manufacturer the way we develop the application and splitting the core software in several modules, being able to reuse the modules we develop to create new products quickly. So I think it's clearly a trend.
Obviously, I think there's a general agreement that this is an area in which we're seeing a lot of disruptive technologies. Kuban, I know that obviously you've got a very specific interest in that. Can you sort of outline Zero Density's sort of approach to this trend?
Yes, we are not even developing the rendering engine, for example. We take it to the next level. We say that if someone is developing a component very good, let's use that. For example, for rendering, we are using Unreal Engine, which is a game engine. And on top of it, we add our IP. So we don't develop anything that someone has developed before. So we are gaining lots of time, and it costs a lot less because we don't develop it again and again. So the software could be reused even between companies. But the hardware design, it's not that reusable or not easily that kind of licensable maybe. It's hardware.
Yeah. So a few general questions for anyone to come in on. Obviously, as Ryan has mentioned there, the whole issue of FPGAs and obviously having large combinations of those has got inherent drawbacks. Are we going to see a new generation of processing technology come through that sort of power this trend, facilitate this move away from hardware, do you think?
Yeah, definitely. I think that what we see and with the power of GPU, it offers functionalities and a way to develop that is close to what we can achieve with FPGA. There are also some evolutions with Intel and the way they design their processors, with possibilities to integrate some acceleration with FPGA. So that is probably also changing the way we can design the products by combining the best of the two approaches, because there are simply some functionalities that are more efficient to process and to perform in something in a form which is not a pure CPU.
Yeah. Okay, so.
Do you have a view?
Instead of having to rely on specific SDK and API and specific vendors, board and hardware processing unit, I mean leveraging of the self GPU and even in the cloud instance. So it's much more easy to create a future-proof software which will accommodate to easily to any new model of GPU. So developing in the standard with the standard API helps to get a continuous improvement without having to disrupt or sell expensive upgrade each time a new generation of product is going out. Keeping the software approach and leveraging COTS equipment is definitely something attractive for all.
I mean, to what extent do you find that the broadcasters you're talking to have already got their head around this particular idea and are keen to make that transition? Or is it at a fairly early stage of awareness, would you say, that this is happening and it's something they need to plan into their purchasing decisions?
On our side, I think it's still an early stage of reflection for the broadcasters that we are talking to, even though we see some of them who are already moving in that direction. So we have one big customer in North America who has decided to go with full software ingest solution with us, running on COTS hardware. So this is something that we can provide as a solution for specific use cases at the moment, but it's not the majority of the request, because obviously there are challenges around that in terms of performance guarantee and things like that. That when you are in hardware domain, exactly the specification of what you can run. When you are deploying a software solution on a COTS, which can be of many different types, then there is the performance issue, there is the maintenance issue. How do you make sure that the different updates that you deploy there will not cause any breakthrough into your workflow and things like that. But we are working with this customer to make the transition to this kind of model, so that when the majority of the customer really sees that this is a trend they can adopt, we would be ready with that.
Because, I mean, it's not just a technological shift, is it? It does require a change of mindset.
Indeed. So it is really the skills of the people that need to change for that. So it's not if something is breaking, it's not just a card that you replace and then you're good to go. So troubleshooting this kind of installation is requiring other skills than the one that the traditional broadcast engineers have today.
Would you agree with that?
Yeah, and what I also see is that, we had our first panel talking about the migration to IP.
Yeah.
Yeah, and if we utilize IP transition in a very good way, then new opportunities arise. And then I think the transition to software-based environments will accelerate because of the adoptions of IP. And also, IP can be maybe the enabler to make that kind of moves. But also during the first panel, Phil Myers was mentioning we still need in a lot of applications hardware acceleration, and I agree with that in various cases. And IP will also allow that this hardware acceleration can be virtualized. And then those kind of hardware acceleration products based on FPGAs can be positioned in the cloud, if that's the nice word to say. But we also see that customers, also here in Europe, are using that transition to IP also to centralize hardware equipment, to utilize the equipment in a better way, and drive it in a more cost-effective way, in such a way than the traditional dedicated hardware for a dedicated production. And that, with the transition to IP, and Jan Eveleen's also mentioned the speed that is required to allow this, will take some years to overcome, but it's a matter of years that will allow that.
So really, a lot of the developments we've been talking about today are kind of mutually beneficial if they can be implemented at the same time. Is that fair? Well, I'm saying that in terms of remote production, IP and so on, moving away from bespoke hardware, all of these trends can actually work well together if they're implemented and planned effectively.
Yeah, so then the hardware will exist at processing power. Yeah. And that can be a computer or CPU or a GPU or an FPGA hardware acceleration. But then the main hardware, and that's where Rainer still has his business around, is the user interface. Yeah, how to operate. We are here all together about production in live environments. And in live, it all has to do with the human interface and the response and the creative tools that is under our fingertips. And that piece of hardware will remain for a long time.
Kuban, do you think that given the nature, the sort of fast-changing nature of developments, we're going to see more disruptive technologies coming from newer companies or smaller players rather than necessarily the bigger vendors?
That's another subject, I believe, that I'm not professional with, because I can't really say that. But technically speaking, I can say that hardware will, the off-the-shelf hardware will be so much powerful in the future that we won't need dedicated hardware designs, not as much as we do today. It's becoming, less and less important to design dedicated hardware. You can look to this from, say, audio perspective. You remember in the 80s, 90s, if you go to a sound studio, you would have racks, and in those racks you would have lots of signal processing devices, and lots of signal processing devices connected to, between them you have lots of audio cable connections, because you had dedicated hardware for audio effects and processing. Today, it's very rare. And when you go to a concert, you can't even see in a concert the guys playing the instruments. They have their laptops, and their instruments are connected to their laptops for the digital processing, and they use their personal laptops during live concerts for audio. So do you see dedicated audio hardware designs as much as you do back in the 90s or 80s? Okay, the CPUs are perfectly capable of doing that for last 2 decades. You can do real-time audio processing using CPUs. Now, it's the time for the video. We always think that we need dedicated hardware and dedicated bandwidth and processing power to do that. Okay, you need that. But now the parallelism that you can have on a GPU is so much compared to the CPU, the bandwidth and the parallelism, the processing power, and you on a GPU you have several thousand cores. Several thousand cores means several thousand processors running between 1 or 2 gigahertz, which means they are doing 1 billion and 2 billion operations with several thousand cores. And on the memory, you have around 1 terabyte of bandwidth. This is the latest generation of the GPU, which is used for gaming, around $1,000 something. So you basically have lots of powerful processing speed on the GPU that you can guarantee, and you can have lots of overhead to drop speed of processing. As the thing is, so far we have done it the old 90s audio processing way. We create one box that does something with some custom FPGA and PCB designs, and we connect them through SDI. Now we try to connect them with IP. Doesn't matter. The thing is, it's not only transition to IP. Why do you interconnect processing devices? Because some company designs some component which has an input and output, and it's a dedicated hardware that it does something specific. It has an input, it has an output. You can communicate only that way. What if all the code of the companies are running on the GPU? What if those codes are becoming nodes? Node-based compositing, if you know the concept. So nodes are representing the boxes in your physical racks, and the connections between the pins of the nodes are representing the STI connectors. So why are you trying to physically, electrically transmit the data from one device to the other device? Because you lack processing power with GPU? It's not. So what if you can bring all the intellectual property of the companies as the GPU code? And with virtual nodes, virtual boxes, you connect them in the GPU memory. You don't need cables at all. You don't need connectors, not even IP connectors. Of course, from the physical world, like from the camera, you would need the signal. And to display something on the monitor, you will need some output. But all the processing in between and racks of machines, they can be connected within the memory of the GPU because they have thousands of times processing power that you could have with dedicated PCB design and some FPGA.
I mean, that concert and studio example you mentioned there, where, for example, physical EQs and channel strips are now being produced as software recreations and plugins for various digital audio workstations, that transition has happened very successfully in the music industry, hasn't it? And manufacturers and distributors have got around that concept, from moving away from selling physical boxes to selling plugins quite successfully. Do you think that can be achieved in broadcast over time?
That's my dream.
Yeah, that's your dream. But particularly for the distributor,
we don't ask you to wake up. Don't worry.
I think,
but particularly for the distributors, it's a big change, isn't it?
I think that a well-structured software solution is already composed of multiple processing, what we call microservice today. To come back to your previous question about newcomer and small company and so on, the beauty of that is that you can easily integrate specific features, specific services, and Lego bricks, and create a software solution based like a Lego bricks. So it's much more faster and scalable to make your product more appealing with more features with this pure software approach. And for an integrator perspective, they will certainly become more and more IT-oriented and IT specialists. And they will have to do this kind of multiple software integration on their own, while they were integrating a router and SDI, BNC cable in the past. Now it's more about how to make this software talk to each other and achieve like a real workflow, and being able to repurpose all these different software bricks to achieve different kind of production workflow. Ideally on the private cloud first, and ideally on the public cloud, maybe in the futures, if we don't talk about security topics here. But yes, definitely this software approach offers kind of, let's say, scalability and flexibility and modular approach.
I mean, do you think it will actually accelerate the convergence that we already see between the broadcast and IT professionals, like sheer nature?
Yes, it is.
Yeah.
It is already right now. And it's up to the vendor to pay attention to, let's say, the platform, the customers of the shelf components they want to qualify their system on, because a qualification is always needed, even when you design a pure software solution. And as a hardware vendor as well, Simplylive qualify equipment and build equipment. But based on our specification, you could build it on your own. Yeah. And our software can already run on Amazon V4 or T100 instance in the cloud, leveraging GPUs, like you said. So yeah, there's some still bits of hardware qualification, but leveraging a rack full of COTS system is definitely much more important in nowadays business in terms of total cost of ownership in infrastructure.
Yeah, and I think new companies or newcomers in the industry are important to keep us awake and to understand what's going on. And I like to be part of your dream. And it's good that Kuban is coming from the gaming industry. And I always keep a close eye on the gaming industry, because we think that in broadcast we have the highest bandwidth requirements and the highest processing power requirements. But if you look to the gaming industry, they are running not at 50 frames per second. That's the gamer can probably even not play the game if it is running at 50 frames per second. And if we look carefully to those kind of technologies and the way how they embraced CPU and GPU power, I think the broadcast industry can learn a lot from that area.
Okay. I would say that even if I can definitely see your dream, and that's something that is really appealing, there are still some challenges in the industry as we see it today. And I think that when you look at the hardware equipment and the way it's handled today, I like your analogy. You take input and outputs. Yeah, it's you take an SDI cable, you plug it in, you put systems together like that. Rainers, that's your job of every day. If we want to do that in a software world, that's a different story. We are not talking anymore about SDI cables to put together, but that's piece of software that need to have defined, well-defined APIs and people that develop software on top of that to make that happening together. I think that the industry as a whole is not yet there about standardizing. We are just standardizing the way we are exchanging the video at the signal level. We're not yet at the level where we can do that at the application level.
So we will be requiring a new generation of engineers who can work at this very high level of software integration, essentially.
Yeah, indeed. So, and that's definitely an investment that we are doing to hire different skills than we had previously. So the majority of our developers are software developers with people working on different kind of technology, artificial intelligence, GPU. So it's not only FPGA anymore that we need to build those kind of equipment.
Yeah, I mean, just to pick up on AI briefly, do you think that will be an enabler of this trend? And in what kind of ways are we going to see AI?
It's definitely something very important in the automation part, because that's something we see very important. Obviously, we all know that the industry is under pressure with the costs. And automation is something very important to answer that. And so artificial intelligence is definitely an enabler to do more automation through machine learning. And this is why we have been developing a few ideas around that. Now working with automating, for instance, the camera positioning for some specific position in sports. So that is something where we see there could be definitely beneficial in the approach that we can take with AI.
What kind of time scale do you think we're going to see for development? Is this still some years off, would you say?
No, we're actually working on that right now. So
Okay.
this is something that is possible today, yes.
Yeah, okay. Do we think this will be a truly global trend, or is it going to be sort of something that's more restricted to the most developed broadcast markets at the moment in terms of this?
I think we have to see that as a global trend and be able then to reuse and pick up the components that you see in other markets, integrate that in the broadcast industry and add the layer on top of that, which makes the specificity of what we are doing. That's definitely the way to go, because we are in a small industry. So if we always have to reinvent everything by ourselves, we will not progress any further. So we have to take components that exist in other industries, integrate that, and put the layer on top of it, which makes our specificities.
Marcel, do you think that you say the business model of a company like Grass Valley will be changing fundamentally over time?
Yeah, well, if this trend continues, and it will, then we also see that manufacturers and their customers will find ways to invent new business models as well. And if it is talking about selling software, but you also can offer software as a service, those kind of aspects are aspects that comes together with the trend of moving away from dedicated hardware. Yeah. And the business have to come with it. And what I mentioned earlier, the value of the software needs to be seen in the industry and how that evolves. And it will take time to adopt from a hardware-oriented business model also at the broadcasters towards the manufacturers. And that transition will probably a bigger hurdle than the technology hurdle.
Will that be a sort of a generational issue as well? You know, once the next generation comes on stream at the broadcasters, who are more used to working in a virtualized way, that they, you know.
Yeah, I don't know what is the average age in this room, but I think the new generation probably is more adopting this in a faster way and understands, hey, if I want to play a game, I have to spend some money, and that's definitely also in those kind of models are going to be the new state.
Yeah. Okay, well, we have a few minutes left for questions. We didn't have any questions for the first two sessions, so it'd be nice to have a question if someone has one for our panelists. No? Okay.
There's one.
Excellent.
Will you program cameras within your game software?
Programming cameras?
Running towards the tower or whatever, then you have the camera shot within the gaming itself and not from an outside camera.
I'm not really a game developer, so I think this is a game development question. We are just using the game engine technology.
It's a question then more to Grass Valley. Do you think that your big hardware with the lens will disappear?
Well, probably next time we should invite also Fujinon and Canon as the lens manufacturers if they are going to do the transition to software. But
software lens sounds interesting.
Yeah, but and that's also why Kuban and I are working closely together on all kind of new stuff. And the camera itself representing what's happening in the world, but. The key thing that we did not discuss here, but it's in fact all what we do in broadcasting is what about the storytelling and how we can improve the storytelling to the viewer at home. And if the storytelling can be improved by virtualizing a camera by a rendering engine that is coming from a development that Kuban created, then that helps together with the real world environments that are captured by the camera. So that is definitely an area that we foresee that a camera itself, probably a lot of people think that's something that you never can virtualize. And my statement is I never say never. And I also have a dream. So maybe this is, we have a dream story today. This is something that it all has to benefit the storytelling of the production. And that's key to where all the technologies is going to. But for me, that always is the root of my decisions towards new technologies. How we can improve the storytelling to the end user.
And when you say storytelling, though, obviously we can see the immediate. You can imagine the benefits for sports content, and news content, but presumably we can also be looking at dramatic output here as well.
Yeah, and I had many conversations with producers and content creators. That's well, we are known as Cross Valley Cameras for a very natural look and showing the real world environments. But sometimes it's something that in a story needs to be artificial, and that combination is very interesting for me to understand. Those kind of creative elements in the storytelling, and if it is a dramatic production or a sport production. But it have to enhance the storytelling. And even in sports, well, we all know that even in sports, it's about the story behind the players, behind their careers, their tactics, their training centers. All those kind of things helps to tell the story during the game. And we are looking as Cross Valley how we can enhance the tools to make that storytelling to the producers in a more easier way.
From my own experience, I just interviewed a director recently who was talking about how HDR is now, for example, he regards that as part of his creative arsenal. So one can imagine this also being a similar story in time as people become aware of the opportunities that it presents.
Yeah, well, and that's more in line with trying to reproduce the real life world in a more natural way. And we had this HDR dream already 10 years ago. Yeah. There was no display in that time, but the camera was already able to capture. But that's something that helps to enhance the viewing experience.
Yeah. Yeah.
You support your storytelling feature, but within the real-time sports, of course, your camera is at the moment something where hardware is needed. But within the storytelling of e-gaming, it looks different.
Yeah, and then you see a nice combination of what's happening in the e-game or in the game and what is happening on the face of the player. Yeah, and that even the expressions on the face of the player is important to the viewer and to understand how the gamer reacts and responds. So it's a different combination in esports, but a very interesting one.
Excellent. Okay. Well,
I want to add something.
Yeah, one final word.
I just talked about my dream and about the devices in the racks, but I have some dreams about camera as well.
That's good.
Me
too.
All the cameras have lots of internal processing inside. So the more processing boards that you put inside the camera, the bigger the camera gets, the heavier it gets, and the more power it consumes. And the more expensive it is in terms of hardware design and manufacturing process. So why not just put the lens and put the sensor, read it, and send it to the GPU? Everything else, whatever signal processing you do, color space conversion, matrix, gamma, noise reduction, sharpening, skin detail, whatever, those are all processing, right? And if they are just like processing nodes, which are not PCBs and some FPGA and connected cables inside the camera, you can make a much more hybrid software camera. So make it much more lightweight, making it much more lightweight and less power hungry will also change the physical camera rigs. Because if you have a lighter camera, you can have simpler, say, wire cameras like SpiderCam, or you can have simpler cranes. You will have more rigidity. You can use carbon fiber rigs much more easily because the camera is so light. So why not make a lightweight camera? Move some of the boards to the GPU.
Yeah, so maybe he's doing a job interview tomorrow. But I have that dream as well. So, and that's also what you will see in the future. And I'm not showing our Grass Valley camera roadmap here, but that's definitely something. And their technologies like IP and the transition to IP, something that we do today with direct IP, where in fact, the CCU can be virtualized wherever it is in the network. Is showing already that direction where it doesn't matter anymore where that processing of a CCU is taking place, as long as it's being connected to that same network as the camera is. And that kind of trends we definitely see. There are still some physics and some ergonomics in the story that you were mentioning, and that are important, and that also has to do with the weight of the lens itself and the quality of the lens. So another reason for inviting the lens manufacturers next time. But it's indeed if the camera just becomes a capturing device and all the processing will be virtualized. Also, that's my dream as well. And my business cards say camera systems, not CCUs or other processing things. That is part of the camera business today. But it's definitely something that we already introducing with the direct IP several years ago, where this kind of things can be virtualized and the processing doesn't matter anymore where it is. And next steps definitely will follow, and let's have the job interview next time.
Yeah, maybe we will mount your camera to the lenses.
That's what we do. Yeah.
But regarding size, I mean, they will be so small, so that you can mount. You just carry the lens right now. There's a sensor at the back, very small and lightweight.
That's good.
We shouldn't give away all of your R&D plans.
Let's get in the room.
Okay, well, thanks very much indeed for that. Lots of interesting thoughts and predictions there. So if you join me in thanking our panelists. Thank you.
Thank you.